Jai Hind all of you. Welcome to today's online class. As you know, we are doing the lesson coordinate geometry. And in the previous videos, you learned how to find the distance between given any two coordinates. Let me recall you the distance formula once again. Distance formula says the distance d between the 2 points P x1 y1 and Q x2 y2 in a Cartesian plane is given by PQ equal to d equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So this formula is very important. So I think all of you understood very well how we need to find the distance between any 2 points in the previous classes. Today in this class we are going to see application of distance formula. That is, using this distance formula we are going to find for the given 3 coordinates of a triangle, we can apply distance formula and verify the type of triangle formed by the coordinates. What is the meaning, children? We know a triangle is having 3 vertices and these 3 vertices will be given as 3 coordinates of the triangle. Using these 3 coordinates, we need to apply distance formula and find out what type of triangle is formed by these 3 given coordinates. Okay? So we can continue the problems. In the previous classes you learned what are the types of triangles we studied in smaller classes. So here you see type of triangles. First category, equilateral triangle. In an equilateral triangle, you know all the 3 sides are equal. So what is the meaning? The length of the sides of the triangle are equal. That is, distance between AB equal to distance between BC equal to distance between AC. So this triangle is an equilateral triangle. Now the second type, that is isosceles triangle. What do you know about isosceles triangle? Any 2 sides are equal. So here I have drawn one triangle PQR and 2 sides PQ and PR are equal. So PQ equal to PR for this triangle, we can say it is an isosceles triangle. Now come to the third type, scalene triangle. What do you know about scalene triangle? In a scalene triangle, all the 3 lengths are unequal. They are different. Here you see in this triangle XYZ, XY is not equal to YZ, not equal to ZX. They are different. So if the 3 lengths are different, we can say that triangle is a scalene triangle. Now come to the fourth type. What can you understand from this picture? This is a right triangle. If one angle is 90 degree, it is a right triangle. And this fourth type, how will we verify? Using Pythagoras theorem. What do you know about Pythagoras theorem? The sum of the squares of 2 sides, that is here PQ square plus QR square is equal to square of the hypotenuse, that is PR square. So when you verify the Pythagoras theorem, we can verify that it is a right triangle. So these are the 4 types of triangles we are going to discuss in today's session. So we can, I think you understand all of you, equilateral triangle, scalene triangle, isosceles triangle, right triangle. So we are going to see the examples. The first one is to verify the given coordinates for an equilateral triangle. So what do you know? The length of the distances of all the three sides of the triangle must be equal. For a triangle ABC, AB equal to BC equal to AC. So in a triangle ABC, we want to prove all the three sides are equal. Okay? Yes. Example 1. Your first problem. Check whether the given coordinates 0, 0, 3 root 3 and 3 minus root 3 form an equilateral triangle. So here three coordinates are given. We need to verify whether the coordinates formed triangle is an equilateral triangle or not. So how to start the solution? So in the beginning of the solution, you want to take, let the three given coordinates be. You want to assume these three coordinates as three vertices of a triangle. I have given name P, Q and R, and the triangle is PQR. You can give any names. Okay, you can give any name of a triangle. So here I have taken PQR, and we need to, what are the three distances then? PQ, QR and PR. Okay, right. So we are going to find these three distances PQ, QR and PR using distance formula. Let us continue. So to make the calculation easier, I have written for finding the distance PQ. How will you do, children? P will be our x1, y1 and Q will be our x2, y2. So write the coordinates on the side of the calculation that is working column. Then you can apply the distance formula very easily. Okay. So we can first find out what is the distance PQ. So how will you do? PQ equal to, first you write down distance formula, that is x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, that is equal to, what is x2 here? 3. x1 is 0. So 3 minus 0 the whole square. Similarly, y2 is root 3, y1 is 0. So root 3 minus 0 the whole square. Okay, right. So we are writing root of 3 minus 0 the whole square plus, what is here? Root 3 minus 0 the whole square. So what is the simplification? That is equal to 3 minus 0 the whole square is 3. So 3 square, root 3 minus 0 is root 3. So what is root 3 square? Root 3 square is 3. Correct? So that is equal to 3 square is 9 plus 3. What is 9 plus 3? 12. So our answer is root of 12. So first distance PQ is over. Now we are going to the second distance QR. So what is QR? Again root of, here you see x2 minus x1, 3 minus 3. 3 minus 3 the whole square plus, here you see y2 is minus root 3. So minus root 3 minus root 3. Okay, minus root 3 minus root 3 the whole square. So that is equal to, what is 3 minus 3? You know 0. So 0 square is again 0 plus, what is minus root 3 minus root 3? You learned in 9th standard how to add rational numbers. Here minus root 3 means it is minus 1 root 3. Similarly here also minus 1 root 3. So when you add these two numbers, we will get minus 2 root 3. Okay, minus 2 root 3 the whole square. So the simplification is 0 is we need not take. So minus 2 root 3 square means minus square will become plus, 2 square is 4 and root 3 square is 3. So that becomes 4 into 3. That is equal to root of 12. So second answer also root 12. Now come to the third distance PR. Again apply the formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So here you see I have written P and R. Okay. So P is our x1 y1, R is our x2 y2. So take the coordinates 3 minus 0 the whole square plus minus root 3 minus 0 the whole square. What is 3 minus 0? 3 square plus minus root 3 minus 0 is minus root 3. What is 3 square? 9. And what is minus root 3 square? It is again 3. Minus square will become plus. So here also you got root of 12. So what you can see in this, the length of the 3 distances are equal. So how to conclude? Therefore PQ equal to QR equal to PR. So what you can understand? Hence this triangle PQR is an equilateral triangle. So that is the conclusion of this problem. So we found out the length of the 3 sides and we concluded that the sides are equal, therefore it comes an equilateral triangle. Understood, children? Okay. Yes, now come to the second type of the triangle. To verify the coordinates for an isosceles triangle. And what do you know about isosceles triangle? The length of the distances of any 2 sides of the triangle must be equal. So any 2 sides, if you prove they are equal, then it is an isosceles triangle. Now see one example in that type. Check whether 5 minus 2, 6, 4 and 7 minus 2 are the coordinates of an isosceles triangle. Right? Now start the solution. First you need to take the given coordinates B. Here I have taken A, B and C for a triangle ABC. So we need to find the distances AB, BC and AC. Okay. If you have confusion, you just draw a triangle on the side. You can understand what are those sides, AB, AC and BC. So we need to find first AB. So I have written here A and B. A is our x1, y1 and B is our x2, y2. Write the coordinates of those vertices. So first AB. What is AB? First you write the formula once. x2 minus x1 the whole square plus y2 minus y1 the whole square. Now see the coordinates. What is x2? 6. What is x1? 5. So 6 minus 5 the whole square plus 4 minus of minus 2. Be careful there. Here minus of minus 2 will becomes plus. So y2 is 4 minus of minus 2. Okay. Minus of minus 2 square. So in the next step you will get what is 6 minus 5? 1. So 1 square plus 4 minus of minus square, that is 4 plus 2, correct? Root of 1 plus, what is 6 square? 36. What is 1 plus 36? 37. So your first answer is root of 37. Correct? So we got the first distance AB equal to root of 37. Now we need to find the second distance BC. So see children, B is x1, y1 now and C is x2, y2. So BC equal to root of, what are the coordinates? x2 is 7 and x1 is 6. So 7 minus 6 the whole square plus y2 is minus 2, y1 is 4. Minus 2 minus 4 the whole square. That is equal to, what is 7 minus 6? 1. 1 square minus 2 minus 4 is minus 6. Minus 6 the whole square, that is equal to root of 1 plus minus 6 the whole square is 36. Again you got the answer root of 37. Okay, so the second distance also came root of 37. Now come to the last one, AC. Now A is our x1, y1 and C is our x2, y2. Write the coordinates. So AC equal to root of 7 minus 5 the whole square plus minus 2 minus of minus 2. Correct? Here also one minus is there. So minus of minus 2 will become plus. So minus 2 plus 2. Okay. The whole square. That is, what is 7 minus 5? 2. 2 square minus 2 plus 2 becomes 0. So take only 2 square. 2 square is 4. And you know root of 4 is plus or minus, that is 2. Root of 4 is 2. Square root of 4 is 2. Thus, you got the three distances. First we found AB came root of 37. Second distance BC came root of 37. And third distance AC became 2. So what you can understand here? First distance and second distance, that is two sides length are equal. Correct? Since AB equal to BC, that is any two sides length is equal, we have, what is our triangle? ABC is an what triangle? Isosceles triangle. So thus we concluded this triangle is an isosceles triangle. Okay. Hope you understood the problem very well. Right. So we can see now the third type of triangle. Okay. Yes, what is the third type? To verify the coordinates for a scalene triangle. And you know what is scalene triangle? The length of the three distances of the sides of the triangle are unequal. If all the three lengths came unequal, then the triangle is a scalene triangle. See the question for this type. Check the type of triangle formed by the coordinates 2, 4, 4 minus 2 and 7, 1. Now start the solution. Let the given coordinates be P 2, 4, Q 4 minus 2 and R 7, 1 of a triangle PQR. We need to find the length of the three sides. What are the three sides? PQ, QR and PR. So first length is PQ, so that I have written P x1 y1 and Q x2 y2. Write the coordinates. Now the first distance we are going to find PQ. Write the formula as usual, distance formula x2 minus x1 the whole square plus y2 minus y1 the whole square, that is equal to root of, what is our x2, y2? x2 is 4, x1 is 2. So 4 minus 2 the whole square, and here y2 is minus 2, y1 is 4. So minus 2 minus 4 the whole square. And what is the simplification? 4 minus 2 is 2. 2 square plus minus 2 minus 4 is minus 6. Minus 6 the whole square. What is 2 square? 4. And what is 6 square? 36. So 4 plus 36. So you will get the final answer 40. So first distance came root of 40. Correct? Now we want to find the second distance QR, then PR. So see children, for QR, Q is our x1, y1 and R is our x2, y2. So we can find what is QR. QR is equal to, write root of, x2 is 7 and x1 is 4. So 7 minus 4 the whole square plus y2, 1. Minus of minus 2. Here one minus 2 is there. So 1 minus of minus 2 will become 1 plus 2. The whole square. That is equal to 7 minus 4 is 3. 3 square plus 1 plus 2 is also 3. 3 square. 3 square is 9 plus 9. So your second answer is root of 18. Okay. Now the third distance, PR. P is our x1, y1, 2, 4 and R is our x2, y2, 7, 1. So we can find out PR equal to root of, again formula 7 minus 2 the whole square plus y2 is 1. So 1 minus 4 the whole square. What is the answer? What is 7 minus 2? 5. 5 square. 1 minus 4 is minus 3. So minus 3 the whole square equal to root of, what is 5 square? 5 square is 25 plus minus 3 the whole square is 9. Therefore, you are getting 25 plus 9, that is 34. So your answer is 34. Okay. Thus, we got PR equal to root of 34. So what is your answers? We got first answer PQ equal to root of 40. Second answer QR equal to root of 18. And third one PR equal to root of 34. So you see the three distances, they are different. Therefore, PQ not equal to QR, not equal to PR. So what is the conclusion? The triangle PQR is a scalene triangle. So this triangle is a scalene triangle. Yes children, understood? Yes. Now we can see the fourth type of the problem. What is the fourth type? Right triangle. Okay. The fourth type, to verify the coordinates for a right triangle. So in order to prove it is a right triangle, first you need to find the length of the three distances of three sides of the triangle. And what we are doing? We are verifying Pythagoras theorem. And Pythagoras theorem, that is, if in this triangle you see PQR, PQ square plus QR square is equal to PR square. In this triangle PQR, then we can say this is a right triangle. Okay. So Pythagoras theorem we are using for proving the right triangle. Now come to the example. Check whether the coordinates 1, 1, minus 2, minus 5 and 3, 0 form a right triangle. So start the solution. Let P 1, 1, Q minus 2, minus 5 and R 3, 0 are the coordinates of a triangle PQR. So we need to find the three distances PQ, QR and PR using the distance formula now. Right? Yes. So first we can start with PQ. So in order to find PQ, you see I have written P and Q. P is our x1, y1, Q is our x2, y2. So first we can find out PQ. Write the distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. That is equal to, what is our x2? Minus 2. x1 is 1. So minus 2 minus 1 the whole square plus minus 5 minus 1 the whole square. What is minus 2 minus 1? It is minus 3. So root of minus 3 the whole square plus minus 5 minus 1 is minus 6. Minus 6 the whole square. That is equal to minus 3 square is 9. Minus 6 the whole square is, minus square will become plus. So 6 square 36 and 9 plus 36 is 45. So the first answer is root 45. Now the next side QR. For that Q is our x1, y1 and R is our x2, y2. Write the coordinates. Now find out QR. Again root of 3 minus of minus 2. When the second coordinate is having first minus sign, you will be careful. 3 minus of minus 2 becomes plus. So it is 3 plus 2 the whole square plus 0 minus of minus 5. Again it is plus 5. So 0 plus 5 the whole square. Correct? So that is equal to, what is 3 plus 2? 5. 5 square, and 0 plus 5 is also 5. 5 square. So your answer will come, 5 square is 25. 5 square is 25. Therefore it is equal to root of 25 plus 25 is 50. Second answer came root of 50. Now the third side, PR. For that, PR equal to root of x2 minus x1. P is our x1 y1, R is our x2 y2. 3 minus 1 the whole square. 0 minus 1 the whole square. That is equal to root of, what is 3 minus 1? 2. 2 square. 0 minus 1 is minus 1. Minus 1 the whole square. What is 2 square? 4. What is 1 minus 1 square? 1. So 4 plus 1. What is 4 plus 1? Root of 5. Thus you got PQ root 45, QR root 50 and PR root 5. Next we are going to verify Pythagoras theorem in order to prove this triangle is a right triangle. Okay. So first we want to note down all the 3 sides. Okay children. Yes. So we have written the 3 distances PQ equal to root 45, QR equal to root 50 and PR equal to root 5. So in order to verify Pythagoras theorem, we need to square the 3 distances. So if PQ equal to root of 45, what is PQ square? Root of 45 square. When you square root of number, the root will go. Therefore, the answer is 45. Similarly, next one, QR square, you will get root 50 square. The answer is 50. And third one, PR square, that is root of 5 square, will become 5. Now, you see children here, PQ square came 45, QR square came 50 and PR square came 5. What happens when you add PQ square and PR square? PQ square plus PR square, you will get 45 plus 5. And what is 45 plus 5? 50. And what is 50? Our QR square. So that means in this triangle, when you find the square of the 3 sides, the sum of the squares of 2 sides came equal to the square of the third side. So who is this third side? The hypotenuse. And using the Pythagoras theorem, when you consider a right triangle, this QR is our, this will be 90 degree and QR the hypotenuse and P will be here. So you can say PQ square plus PR square is equal to QR square. So what can you understand? Using Pythagoras theorem, the angle is at P is 90 degree. Correct? So using this verification, we consider this triangle is a right triangle. So how to write? Therefore, angle P is definitely 90 degree and hence using Pythagoras theorem, what is the name of the triangle? PQR is a right triangle. Thus we proved this triangle is a right triangle. Okay children, understood? Yes. So So let us revise the lessons what we studied today. Keep in memory. First point, for an equilateral triangle, all the three lengths of the distances of the sides are equal. Number 2, for an isosceles triangle, any of the two lengths of the distances of the sides are equal. And for a scalene triangle, all the three lengths of the distances of the sides are unequal. And the last one, for a right triangle, find the length of the distances of the three sides of the triangle and verify the Pythagoras theorem. So this is the thing what we studied today, the 4 types of triangles verification. So all of you keep all these points in your mind very correctly and do the examples, your works also properly. Okay? Yes. Now from today's lesson, I will give you some homework. All of you see this. From the 4 types of triangles, I have given 4 problems. First one is for checking an equilateral triangle. Second one for isosceles triangle. Third one for scalene triangle. And fourth one for right triangle. Okay, so take down all the problems. Do the homework correctly. And complete your notes before the next class. So all of you understood today's class very well. Keep up to date your lessons. Okay children, thank you very much.